Good morning, this is your Stat Sensei, Mr. Spensei, and this is a hypothesis test for a two-sample T, and this is going to be scenario smartphone dumb kids. A study is conducted by a group of educators investigating whether excessive smartphone use negatively impacts students' academic performance. While phones can be a source of distraction during study time, they may also serve as educational tools for accessing study apps and notes. To analyze the relationship between smartphone use and academic performance, a random sample of students was selected from a large metropolitan school district with over 25,000 students. All right, so we have a very large population. Two independent groups were formed based on smartphone usage. The first group consists of 63 students, all right, who use their smartphones for more than 5 hours a day. So we have 63 students that were randomly selected, and it should have said that they're randomly selected, and they use it for more than 5 hours a day, randomly selected from thousands of students. There it is, randomly selected from thousands with similar phone usage. The second group included 37, so a much smaller group who use their smartphone for less than 2 hours a day, randomly selected from the 1,500 students with comparable phone usage. The findings are summarized in the table below. Okay, so we have high smartphone use at 2.5 hours and low, I mean, the mean GPA. So the average GPA, grade point average, for high smartphone usage, those who used it more than 5 hours is 2.5 versus low having a 3.4. And here's our standard deviation for each. All right. So this is going to be the high smartphone use and a low smartphone. The educators aim to compare the mean academic performance measured by students' grades between the two groups to determine whether smartphone usage has a significant effect on academic um, outcomes. The educators will test whether the high smartphone usage has a significantly lower GPA than low smartphone usage. So we're going to basically say, okay, our ha is going to be high has lower GPA than low. All right. High usage has lower GPA than low usage. That's what we're testing. Okay. So we're doing a two-sample t-test. We have two independent groups, so we're going to need to use a two-sample t formula, and here it is. All right. And they're asking us to test at an alpha of 0.01. So sample mean 1 minus sample mean 2 divided by the standard deviation of sample mean 1 squared over its sample size. And this will be our low usage group, sample mean, the standard deviation for this second group, and the sample size for the second group. So when we do that, we can just pull that information straight off the table, or most of it. We have 2.5 GPA, and this is our GPA for this. And this is a 0.9 GPA. And they told us up here when we were reading that they had a sample size of 63 people with a high phone use that they randomly selected. They said the GPA for the low usage was 3.4. So we can see that they have a higher GPA, but we don't know if it's statistically significant or whether it happened by random chance alone. And they have a sample standard deviation of 0.8, so 0.8 GPA, and the sample size is 37. And once again, that was up here. They told us it was 37. Okay, we're going to run a two sample t test for means. And by the way, if you forget that, you can go stat test and you can drop down to number 4. Oh, two sample t test. So we just wrote it out what they had there. All right, so we need to draw our picture. Now, the one thing you have to remember is that hypothesis tests are centered on the mean. In this case, are centered on mu1 minus mu2. Now, confidence intervals are centered on x bar 1 minus x bar 2. But on a hypothesis test, the assumption is that the means are equal. So our null hypothesis will be mu1 equals mu2. Well, that can be rewritten as mu1 minus mu2 equals 0. So we know we're going to be centered on 0. So that part's going to be easy. So we can go ahead and, all right, mu1 minus mu2 right here, mu1 minus mu2 equals 0. And that's where that 0 comes from. All right, when we subtracted, because now we're looking for x bar 1 minus x bar 2, and I know that doesn't show up really well because it's kind of small. We have x bar 1 minus x bar 2, and all we did was go 2.5 minus 3.4. 2.5 minus 3.4. And we got negative 0.9, and that's where that came from. And they told us they wanted to know whether high usage was less than lower usage. And they were talking about the measure of GPA. So then we're just plugging into our formula. 2.5 for x1 and 3.4 for sample mean 2. Here's our sample standard deviation for the high usage and our sample size for the high usage. Please make sure that you square these, all right? Please make sure you square the standard deviations. For the low usage, they had a mean GPA of 3.4 and they had a sample standard deviation of 0.8. Once again, make sure you square it, divide by 37. All right, we've already said that we're running a two-sample T, and I've already mentioned above that our mu, the claim is that there is no difference. That's the assumption. So, or this can be written like this, mu1 minus mu2 is equal to 0. Please remember, the null hypothesis is always going to be written as equal. And if you subtract the 2, if this had been a 3 and this had been a 3, 3 minus 3 is 0. So if they're equal, when you subtract them, they're going to be equal to 0. The alternative hypothesis could have been written this way. One I could have subtracted, all right? But remember, mu1 is the high GPA, and we expect, the high usage, and we expect them to have a lower GPA. So if they had a 2 and this one had a 3, 2 minus 3 is negative 1. Negative 1 is less than 0, and that's why it goes like that. I much prefer to write it like this. I think it's easier to keep in mind. And make sure that you recognize it could be written like this. All right, since we have mu1 and mu2, we need to define those parameters. All right, and we have two parameters. So let's let mu1 equal the true population mean GPA for those with high smartphone use. All right, so that's the population mean that we're trying to estimate with our sample mean of x bar 1. And we estimated the single value, or we got a 2.5 from our sample. And those with let mu2 equal true population mean GPA for those with low smartphone usage, we get 3.4. All right. Our conditions, high smartphone use, random sample. Oh, first off, we have two random samples. All right. One of 63 and one of 37. I like to combine these two together and say, hey, we have two independent random samples, one of size 63 and one of size 37. And this is given. All right. Also, we know our sample size was 63. 63 times 10 is 630. And high smartphone use, they said, was randomly selected from thousands. So I'm just going to add apostrophe S to make that thousands. All right. And when we look at the low smartphone usage, the second group of 37 was for less than 2 hours, randomly selected from 1,500. All right. And we have 37 times 10 is 370. 370 is definitely less than 1,500. So we can say N is less than 10% for both groups. %10 of the population both groups. All right. And 63 is definitely greater than or equal to 30, so we're normal by central limit theorem for this side. And on this side, 37 is greater than 30, so we're normal by central limit theorem. So both samples are large enough to proceed. When we go ahead and run this test, stat test number 4, two sample t-test, we have a 2.5 with a standard deviation of 0.9. And we said we had a sample size of 63, which is right here. We also have a sample mean of 3.4 for the low usage with a standard deviation of 0.8 for the low usage. And their sample size was 37. We wanted a less than because that was our alternative. We never pool. And we end up getting a t statistic of negative 5.1828 and a p-value of negative e to the negative 7. So 1, 2, 3, 4, 5, 6, 7, because this is where it says, so I'm going to have to move this thing 7 places. As soon as I have 4 zeros in front, I can say it's approximately 0. All right. Well, our alpha level is 0.01. And that was given to us way up here. And 0 is definitely less than when we make them the same length. 0 is definitely less than 100. So our decision is to reject the null. Our p-value is approximately 0, which is less than our alpha of 0.01. As always, p-value 0, less than alpha 0.01. That all comes from right there. Our decision, we reject the null. That also comes from right there. All right. There's sufficient evidence, or there's enough evidence to suggest the true population mean GPA for those with high smartphone use. Hey, true population mean GPA, that is our first parameter. True population mean GPA for those with high smartphone use is, well, what's our alternative say? Because right here is less than, that's what it says right there, than the GPA for those with low smartphone use. And this right here is our parameter for the is our second parameter. That's just a restatement of our second parameter. So please remember, this is from the alternative. This is from our first parameter. This is from our second parameter. And we're just summarizing everything we did. So our p-value is approximately 0, which is less than our alpha 0.01. We reject the null. There is sufficient evidence to suggest the true population mean GPA for those with high smartphone use is less than the GPA for those with low smartphone use. All right. I appreciate you watching, and I look forward to seeing you on the next one. Thank you.